Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss reverse osmosis. Reverse osmosis, popularly known as RO. Nowadays, in every house, almost in every house, they are using RO water filter. Why they are using this filter? It is well known. One proverb is there: water, water everywhere, drinking water nowhere. This proverb means everywhere water is there, but drinking water is not available, not easily available. Means now two-third of our earth is covered by water. Sea water, ocean water, maximum water is only there. And these waters are not we can't drink these waters. These are very, very salty. We can't drink. Everywhere this type of water is there. Two-third water is there. But these are useless for us. We can't drink that water. Only total water available on the earth, it's only 0.03% is available for drinking purpose. Rest waters are useless. Means they are so salty, or if some waters are available, fresh water, but we can't, it is not easily available for us. Then in this regard, in this respect, to get fresh water to drink, that one technique has developed. That method has developed. Then that method, many methods are there, but very, very important, most important method is reverse osmosis. By this method, by this technique, we can get drinking water, fresh water we can get. How we will get fresh water from this salty water like sea water and ocean water? Then to understand these things, two terms we should know. Only then we can understand. First term is osmosis, and second term is osmotic pressure. If we will understand these two terms, then we can understand reverse osmosis. Then I am telling these two terms first, then I will come to the reverse osmosis. First, what is the actually osmosis? That we have to understand. This is very, very important term, osmosis. Here, just by example, you will understand very easily. Suppose you have salty water also called brine, B-R-I-N-E, brine. Then suppose you have salty water and you want fresh water from this salty water. How will you get? Then for this purpose, we will use on membrane, semi-permeable membrane. In this, some hole will be very small orifice will be there. A small orifice will be there. Small hole will be there. And what is the characteristics of this semi-permeable membrane? It allows only to pass water solvent, just like a pure water, distilled water, that it will allow only that pure water to pass through it, not the salt. correct? Then one side, suppose in the beginning you have some fresh water in the beginning. Other side you have salty water, and between the two semi-permeable membrane is there. Then now suppose that pure water, distilled water, suppose you have taken in one container. Only in the same container partition is there, semi-permeable membrane. One side you have taken this things water, this thing pure water, and other side impure water is there, impure water, salty water. Second side and first side pure water. Then in this process what will happen? One side pure water you have taken, pure water, that is called pure water is called solvent, and other side you have taken ordinary this thing salty water, that is also you can tell solution. Salty water you can tell solution, and pure water you can tell as a solvent. Okay. Then if in the middle semi-permeable membrane is there, then what will happen? That pure water will pass through this semi-permeable membrane and will come towards solution side, and it will come from solvent to solution side until both side pressure will be equal. Both side vapor pressure will be equal. Up to that stage, from solvent side, means water side, distilled water or pure water, from that side it will come to the solution side until both side pressure will be equal, vapor pressure will be equal. Then now we will ask, what is the vapor pressure? Then vapor pressure, again just I will brief you what is the vapor pressure. Actually pure water has highest vapor pressure, highest. Then if you will take pure water in a container, in a vessel, then this water molecules, it will evaporate. Evaporation takes place at all temperature, room temperature also. But if you will increase the temperature, the rate of evaporation will be fast. More and more water will evaporate. Just like in summer water evaporates. All you can say rivers will dry. Wherever water is there, that will escape to the atmosphere. They will go to the atmosphere. Then like that way, here suppose you have taken pure water in a container, in a vessel, this is fully covered. Then water vapor, that this water vapor from solvent side, it will come up over the surface of water. Above that water vapor will come out, and because now it is vessel is covered, container, and that where water is there, that is covered, then vapor can't go outside, that will be inside only, but above the surface of water. Then there will be one equilibrium. It will create one equilibrium. Means this vapor will from the water vapor will go above the water surface, and when vapor will be more, then again that vapor will come back. Then this water vapor will go upside above the water surface, and again it may come back. Then when both rate of going and rate of coming back, if it will be equal, then that situation is called equilibrium. equilibrium. Rate of forward reaction, rate of backward reaction will be equal. Both process will be equal. Means from the liquid it is converting to water vapor, and water vapor when it is coming more, then again it is coming back. Then when both rate will be equal, going and coming, means forward and backward, if both rate, both process becomes equal, then that situation is called equilibrium. Then at this equilibrium, when vapor uh, it is going above the surface of water, then it will create pressure. It will create pressure on surface of liquid water. On the surface of liquid water, this vapor will create pressure. Then this pressure is called vapor pressure. This pressure is called vapor pressure. Okay. Then this term vapor pressure term now I am going to use here to understand osmosis. Then here I was telling you that you have taken that one side you have taken this solvent like distilled water, pure water. Other side you have taken ordinary this ordinary water or salty water you have taken. Suppose you have taken from the sea water or ocean water. That water you have taken one side. Other side you have taken pure water, and in the middle semi-permeable membrane is there. And through semi-permeable membrane, I told you small holes are there, orifice, that is called orifice. It allows only to pass through, it will allow only to pass solvent molecules, only solvent molecules, not solid. Salt it will not allow to pass. This is the characteristics of semi-permeable membrane. Then now if you have taken this thing semi-permeable membrane between the two liquids, one side pure solvent, other side salty water, then what will happen? Pure solvent has more vapor pressure, and other side salty water has, means solution has less vapor pressure. Then from the solvent side, water will go to the solution side, means salty water side. It will go through the semi-permeable membrane until both side pressure becomes equal. This process is called osmosis. Osmosis means from high pressure to low pressure. Water moves from high vapor pressure to low vapor pressure. Correct? Then this passage of this water molecules from high pressure to low pressure through semi-permeable membrane is called osmosis. This is actually natural tendency. This is the natural tendency of flow of water molecules from high pressure to low pressure. This is natural tendency. This is called osmosis. Now you can understand reverse osmosis. Okay. Then now actually our purpose is that to get pure water from salty water. Then how we will get? Then now I am just going to tell that thing. But here now you have understood two terms, vapor pressure understood, and second term osmosis you have understood. Now one more term you have to understand, osmotic pressure. Osmotic pressure. What is osmotic pressure? This you will understand. This after that you can understand the reverse osmosis. Reverse osmosis. Then what is the osmotic pressure? Then it is very easy to understand. Actually both side this pure water side and solution side. Okay, both side solution also creates pressure, just like solvent creates pressure. In the same way in a solution, means salty water, that side also solvent is there, but in that solvent salts are present. That's why it is called solution. Solution means solvent plus a solute is called solution. Then you want from that solution side, in that also solvent is there. Then you want that water, that solvent which is present in the solution, that water you want. Then here first to understand that solution side also pressure is there, vapor pressure, because solvent is there also. And here this side also pressure is there. Then osmotic this side, solvent side, more pressure is there, more pressure. But solution side, less pressure is there, less pressure. Why it is a less pressure, solution side? Then that you can understand like that. I am telling you that water vapor is there. You have not, water is there, and in that water, pure water, you have not mixed anything. Then now water's molecules are coming as a vapor. Freely it is coming upside without any disturbance. That time, whatever possibility is there, all vapors are coming. But now, suppose in this solvent, pure solvent, water side, if you will add some salt, like ordinary salt, what we are using in your house, that is called sodium chloride. In kitchen, what is kept, or sugar also, ordinary sugar, sucrose, what we are telling, anything, anyone you have mixed it in that water, pure water. Then now what will happen, that these sugar molecules or NaCl, anything, salt molecules, anything you have taken, as you will mix it and you will dissolve it, just to stir it, then what will happen? These molecules will dissolve in water. After that, this solute will be equally distributed in the now it becomes solution, because added you have added sugar or salt, whatever be, then it is now uniformly distributed. Then what will happen, that these salt particles or sugar particles, this will also come near the, you can say, surface of water, near the surface of water. Now these particles will will create problem for the water molecules to go outside. It will block their path. They will create problem. Freely now they are not coming. Then less vapor will come upside. Then when the less vapor will come outside, then it will create less vapor pressure. Then same thing is happening here. And salty water, one side salty water, other side pure water. In the middle, semi-permeable membrane. Then solution side, means salty water side, less vapor pressure is there. And pure water side, more vapor pressure is there. That's why this water molecules from the pure water molecules are coming to the solution side, and it will come until both side pressure becomes equal. Then now what is the osmotic pressure? Now you can understand very easily. Then suppose just simply I am telling, just for explanation purpose, suppose this side, pure water side, 1000 bar is the unit of pressure or atmospheric pressure. 1000 unit pressure is there. And solution side, suppose 600 pressure is there. 600 unit pressure is there. Maybe bar, maybe atmospheric pressure. Then what is the difference? 1000 minus 600. That is a 400 difference is there. Then this 400 difference, that is called actually osmotic pressure. This difference means higher pressure minus lower pressure. Whatever is the difference between the two, that is called osmotic pressure. That is called osmotic pressure. Now you can understand reverse osmosis. Now this reverse osmosis I am telling you. Actually you want water from the salty side. In ocean too much water is there, in sea too much water is there. Suppose you have brought water from there, correct? Then that water actually you want. Then what is done actually? Now I told you that water was flowing in ordinary way. In the case of osmosis, water was flowing from solvent to solution. Now you want that it should flow from solution to solvent, reverse. You want to reverse it. You want to reverse it, direction of flow. Then what you have to do? Then now you are understanding principle. Now you understood how water flows from high vapor pressure to low vapor pressure. Then now solution side, if you will apply artificially high pressure more than pure water, if you are applying on solution side, then now situation will reverse. Now solvent which was present in solution, means salty water or sea water, ocean water, whatever be there, that means solvent from salty water side, in solution side, in solution also solvent is there, then that water will now come from solution to solvent side. Solution to solvent side. If you are applying more vapor pressure than pure water, then this actually process is called reverse osmosis. Then here in every house filter is there. Their construction maybe this you can't understand what are inside. It looks very, for the ordinary person, looks very complicated. But now here principle I told you, principle, how it functions, how it works. Then this process actually is applied. This process is applied in the this filter, in the RO filter, reverse osmosis filter. Then now I am telling the principle of reverse osmosis. I have explained how does it work. Now easily you can understand the principle also. In reverse osmosis process, the water is separated from dissolved salts by means of a membrane which permits the passage of water through it, but not the salts. If such a membrane is placed between brine and pure water, water has a natural tendency to flow through the membrane into the brine due to osmotic pressure. This natural process may be reversed by applying a pressure on the brine side higher than that of osmotic pressure. When fresh water tends to flow from brine into fresh water. This is actually principle. Already explained, hence I think you might have not felt difficulty to understand. Very simple. If high pressure more than pure water, if it is applied applied on the solution side, means salty water side. Then from that side only solvent molecule, only water molecules will come towards this side, pure water side. Okay, then you can make big tanks. Big tanks you can make. Big tanks, one sided you just keep salty water from the sea or ocean water. Other side, just to start the process, you can keep some pure water. You can pure water. Then obviously that side, and if you will apply solution side, means salty water side, more pressure, more than this pressure, pure water pressure. Then from this solution side, in solution side, whatever pure water was there in solution, that will come to the towards the pure water side. In that tank it will come. Then that water, then now 3 pipe. Now you have seen that many this many pipes. You will think that in filter you will see many pipes. Then actually there are three pipes. 3 pipes only. From the one side, from the one pipe, one tube, you are sending the tap water, means salty water. Here you can consider tap water as salty water. Supply water is salty, that you want to clean it. That is just like you can consider it as this thing, sea water or ocean water. Okay, it's not ocean sea, but I am telling ordinary water also is salty. Then from the one tube or one pipe, you are sending the this things, water, tap water you are sending. Okay, and in a second pipe, from the second pipe, what is happening, that after filling the these things, after filling the this after collecting the this fresh water from the, after filtering, water has collected, that you are collecting. That is a 2 pipe that you are knowing. One side water is going, other side water is coming. One more pipe is there. One more pipe tube is there. Third. What is that? Then third is that that now suppose salty water, you have suppose 10 liter. Now there in the market it is available 10 liter, 15 liter, 20 liter, 4 liter capacity there. That tank capacity, they can filter 4 liter, 10 liter, 20 liter, like that. Different capacity it is available. Then any capacity you can take example. Then what will happen? Suppose 10 liter water filter you have purchased. Then 10 liter water you will fill it first. And after that, when it will filter, then after filtering, what will happen, from the salty water side, means ordinary type of water, when it will filter, only solvent molecules are passing through the membrane, okay, semi-permeable membrane. Then that is coming towards the this things, pure water side, which you are collecting and drinking. But here, where in tank you have taken the water, ordinary water you have taken, tap water or sea water, in that, after from that only solvent molecule came, only water, pure water came from this salty water, only water has come, pure water has come, because solvent, because that was mixed in with salt. Now that water has come. Then what happens after coming this filtering? Then salt will be collected, more salt will be collected. That should come out. That salt should come out. Then solid it will not come directly. Then it will come with water only. Then suppose now 10 liter was there, 7 liter you have used. Then in 3 liter, which was salt which was present in 10 liter, now it is present in 2 liter or 3 liter. Then it became more salty. Then to remove this water, one more pipe is there, third pipe. Then it will, that water will come out, third pipe. Okay. then these three are there. One is supplying, other you are fresh water you are you are taking, collecting and drinking, and one more pipe is there just to that this salty water which become more salty now to remove that water. Again, if you after cleaning this, it will automatically it will happen. Then again you can fill this tap of water, you fill it, tap of water again you fill it. Again this case will be it will be repeated always it will be repeated, and you can get as much as water you want. That this I have discussed this I have discussed about the these things reverse osmosis. Reverse osmosis I have discussed. Actually it has a simple formula. Osmotic pressure, one formula is there. Then osmotic pressure, that then it depends upon the concentration of the salt, how much it is dissolved. Okay, on that it depends. It depends upon the temperature, it depends upon the gas constant R, universal gas constant, means osmotic pressure is equal to CRT. Then now I think you have understood what is the this things this thing reverse osmosis you have understood. And here one more thing you have to use. This technique is in many countries. In many countries they are using this technique to get fresh water from the sea water or ocean water, but it is somewhat costlier. But now a scope is there to get the pure water from the sea water or ocean water. And this pressure also here it is required. High pressure is required here. Okay, actually this why it is becoming costlier, because of you have to maintain high pressure. Actually sea water is also called brackish water. Sea water actually is pumped continuously at high pressure, more than 25 atmospheric pressure, through many tubes will be there, because more water if you want to if you want more fresh water, then many tubes you have to apply, just like a tank you can tell. Then brackish water is pumped continuously at high pressure. Pressure is greater than 25 atmospheric pressure. And this water flows from the brackish water into fresh water. One side you apply this things, supply this sea water or ocean water, and other side you can get fresh water. The flow of water is proportional to applied pressure. See, this is the important things or problem or whatever you can tell or condition. The flow of water through the membrane is proportional to applied pressure. How much you are pressure applying, in that way you will get the fresh water. Okay, and this applied pressure depends upon the characteristics of the film. Film means here in semi-permeable membrane one film will be there. Okay, the film may, you can say, rupture under excessive pressure. If semi-permeable membrane has a big role, okay, then it depends of their own film will be there. Through that film water has to pass, that will filter actually. Then if very high pressure if you apply, that film can rupture under excessive pressure. And greater the number of, you can say, tubes what you are supplying water, larger the surface area, and hence more production of fresh water. Okay, then this I have told about the these things, how condition I have told you, that This here one more things I want to tell you, what type of material you will take in a semi-permeable membrane, because it has only this will filter. Then what type of material is used here? Then it is the it's a cellulose acetate. Cellulose acetate film will be there on semi-permeable membrane. This will be made from cellulose acetate semi-permeable membrane. This is actually thin film of cellulose acetate semi-permeable membrane is used there. Okay, and then this high pressure, you have to apply that pressure which this you can say cellulose acetate semi permeable membrane. It should not crack, it should not break, it should not rupture. Then pressure is adjusted. Then I have told you about this how reverse osmosis filter works, RO. How does it work? It is very, very useful, and now it is costlier. It is costlier, but now you will get fresh water in any condition, because this sea water and ocean water will be available every time, even in summer also. River water will dry, but ocean will not dry, sea will not dry. Even the some these things, big rivers also will not, water will not dry fully. Okay, lake, many lakes are there, that also will be available. Then if nearby this type of dirt, even some dirty water is there also, then that can be you can say very dirty. It is difficult, but sea water, ocean water, river water, or this lake water, these are actually river water and lake water somewhat good, but if you want you can filter it, that water. Okay. But ocean and sea will be available anytime, and that water can be supplied all over the world, because 2/3 is water, 1/3 is land. In that also desert is there. Some countries, 15% of the earth, 15% of the earth, it is covered with this only desert like that. Okay, then this technique is very, very useful. I have discussed reverse osmosis. Many other methods are also there, but nowadays many countries they are using this technique. Now I am stopping only here. Thank you.